No, yeah, will not be safe.
Okay. I think this first bit might be the only thing that you forgot. How do you start a confidence interval? It's not the ho and the ha. There's your hint. Okay. Blank percent confidence interval for. Okay. And then hopefully, I'm hoping some people in the room, their brain went the true proportion or P equals the true proportion. Okay. But that's not going to be the case here because we're working on means. So mu equals the true mean and then whatever. So what's really our only update there? When you're working with means, you should probably say that you're doing a confidence interval for means. Shocking. Okay, plan. And I remember the day that we started working on stating the inference method, and you guys were like, why do we have to do that? This is a one sample T interval for mu. Okay, pause there. Which ones do we know before doing today's? So how many options do we have at this point? We have a one sample Z interval for P, a two sample Z interval for P1 minus P2, those are chapter 8. We have a one sample Z test for P, a two sample Z test for P1 minus P2, that's chapter 9. And now you have a one sample, and notice we've changed the Z to T because we're working with means, and this is the T distribution for mu. So I want you to see, like, that's why we have to state the inference method because there's like a bunch of them. And by the time we get to the end, there's going to be a few more. It's not daunting though, I promise. I promise. Okay, anyway, so plant random 10%. Just going to make a note here that let's have your little brain antenna up checking to make sure that you actually even need to do the 10% condition. Okay, so I do want to write a little bit. I don't need to write anything about random, I don't think. I think 10%. We're down with large counts. What's different about large counts? I just want to say it one more time. What do we do for means for large counts? N is greater than or equal to 30. So CLT applies. Applies. Or and you had to do this yesterday in your homework, I saw. What do you do if n is less than 30? Check the graph for normality. Okay, now here's the thing. I gotta tell you, when I say check the graph for normality, unless you are given a multiple choice question or a question that's specifically asking you about conditions, you're always going to go with it, even if it looks terrible to you. And like your one statistic eyebrow that Mrs. Talbot has tried to install into your brain goes like that does not meet normality. That doesn't look normal at all. But then you think to yourself, but wait, Mrs. Talbot said, I can't bail on an FRQ in the middle of the conditions. I just cannot. That is not an option. So I have to assume some kind of normality. Okay, so what we're going to say is, or n equals 30 and graph shows no extreme. I want you to think about when I say this word here, extreme, I'm going to give you two options. You can either imagine a voice in the Slim Jim commercial, or you can imagine a commercial for a monster truck show. Do you know of any of those voices from either a Slim Jim commercial or a monster truck show? Okay, so when I say extreme here, I don't mean regular extreme. I mean like extreme, like that. So the graph shows no extreme skew or outliers. Now, the ones on the homework yesterday, they were specifically asking you about conditions. If there's skew or outliers, you're supposed to say does not meet the large counts condition. No. If you're in an FRQ though, you gotta keep going. You have no option. So you're just gonna be like, well, it's not horrible, so we're gonna keep moving. And you're gonna have that eyebrow. Your eyebrow is gonna be like, I don't know if I should be doing this because it doesn't look normal-ish, but that's okay because Mrs. Talbot told me I have to keep going. That's what's gonna happen. Okay, anyway. All right, so the do step. So I'm looking here at this confidence interval situation. What is the statistic for means? Okay, sample mean, right? What's the symbol for sample mean? X bar. Hold on to the next question. X bar, plus or minus. Okay. Critical value. If you're working with means, which one should I choose? T star. Also, we said T up here, so we should probably T star. Okay, and then times standard error, flip your page over. Standard error for one population X bar is S sub X over square root of n. They don't put the X there. I still do. I don't know if I'm old fashioned or what. Okay, couple of questions. Why does Mrs. Talbot think that confidence intervals are superior to hypothesis tests? Gives you a range of numbers. But can you also make a conclusion from a confidence interval, like a yes or no answer? Yes. If it asks you if something is in the interval or if something's not in the interval, you can say convincing evidence of is it in the interval or is it not in the interval? Just, throwing that out there. Okay. Did you guys already do your arts and crafts business? Okay, go ahead and do that. So this is the rest of that problem. And then this is the rest. Just this on the other side. Ivan, are you proud of my secant curve? Miss Rice was absent and I explained it to Rashawn. And I had to reteach it to myself. But you know what was really cool? I taught the cosine wave yesterday. So I was like, okay, I don't remember any of this, but I did teach cosine today. So if I teach cosine, I can teach myself secant. And I did it. I was really proud of myself.
Yeah.
And then she's gone again today. So she asked me to go get the key off her desk and I checked my answer and it was right. At first I screwed it up because I just graphed regular cosine, but then I realized his problem was secant 2 theta. So then I had to like okay. Anyway, sorry. It was a math moment for me yesterday. Stuff you already know. It's fun that it's like still in my brain. Okay. What? Oh, it's secant. So you graph cosine, and then secant is the reflection of the tops and bottoms. And pre-calc? Yeah, you do.
I wish you.
I don't remember that. No, I think we did it.
Oh, I was.
Oh, you did not.
I do not remember that.
But the calculus.
Yeah, no. Yeah.
Well, it's part of I'm just gonna move on with my non-exposure of my colleagues now. And anyway, okay, so 95% confidence interval. Whoopsie. I didn't even realize what I was doing there. Or mu equals the true mean number of books read by American adults in the last 12 months. Okay, how do they feel about audiobooks? Does it have to be paper? I was just wondering in their survey if they interviewed people and said, was it books? Does it count if you listen to an audiobook? Or does it have to actually like fully eyes on paper? Or kind of like a Kindle account? Anyway. Okay, anything surprising about the state? Perfect. Plant. One sample T interval for means. Random sample. Oh, a lot of big random sample. Whew, I guess the CLT is definitely going to apply here. Great. 10%. N equals 520. Pew Research, by the way, is a real research firm that actually does studies like this. 1520. Of all what? What is the sample of American adults? Do you think there's more than 15,200 American adults? I think we're good. I think we no. Um, okay. I don't know why those conditions are so satisfying to me. Okay. Is anything surprising about the conditions? Good. Okay. So do. So this is probably the part where we need to go a little bit slower. So we want to start with the statistic. Statistic is we're working with means, so that's the sample mean. What's the sample mean in this problem? 12 plus or minus. Okay, and then we need to calculate T star. I'm going to do that over here. That was in yesterday's. Okay, sample size of 1,520. So what is the degrees of freedom? 1519, kind of an awkward number, but that's okay. Let's make ourselves do it for muscle memory purposes. Oh, interesting. Okay, really quick. Does anyone else find this interesting? My super high Jedi math statistics skills tell me that this is interesting. It's exactly the same as what Z star would have been for 95%. And the reason is because the sample size is so high. Should I make an assumption? No, because I have this $150 thing here that can tell me. But anyway, just a good connection. Okay. So plus or minus 1.96 times. Okay. And then that's my T star and then times standard error. So I'm right here. One sample mean standard deviation of the sample divided by the square root of the sample size, which is 18 over the square root of 1520. That look okay? Okay, so I'm going to do 1.96 times 18 over the square root of 1520. And I'm going to say 0.905. Again, the rounding is up to you. I don't know why College Board doesn't just give us a number. I really wish they would, but they will not. They refuse to. Okay, so I go 12 minus 0.905 is 11 point. I feel like I should be able to do this in my head. But that's okay. Oh, I can do that one in my head. Okay, anything surprising in the conclusion? Hopefully not. This is what I'm kind of trying to say about chapter 10. Like you have so much prior knowledge about all this stuff that it just sort of rolls out, which is not bad. You just have to sort of, I don't know, for me, the little mental gymnastics of changing my word proportion to meaning and thinking about things in terms of averages, but I think that is the only difference. Okay, I want to talk about something really quick. It's just a Mrs. Talbot fun thing. So you know how I talk about backwards stats magic, right? And the whole point of being able to make conclusions about a population just from a sample. This, I gotta tell you, this interval is not exciting to me. Do you understand why it's not exciting to me? It's basically telling me it's 12. Like, what other option? What other options do I have? And I sort of feel like I kind of got like, I don't know, manipulated by the system of stats there because the sample mean was 12. Why couldn't I have just used the sample mean as my estimate? Well, I kind of could. And what's the reason? Everything else that we have to do with this class, the sample size was so big that I could sort of kind of tell, oh, well, if that's the mean of that sample, the sample's so huge, I could probably just say that it was 12. So was this rocket science that I did here? Probably not. I probably could have just done a sample that big and have gone with 12. But because we're good students, we went through the procedure and here we are. I don't know about 12 books though, by the way. I'm just saying, do you think the average American adult reads a book a month? No. Okay, if you include the Kindle and audiobook, I think that's gonna bring the average up a lot. I still don't think it's 12. Okay, I guess there's those outliers of the people that read like, a book every 2 days. I have some of those students that are really like super into books. That's it. Yeah. I also probably left way too much room in between B and calculating sample size, but that's okay. Okay, you guys, so just because my conclusions on the other side, guys, I'm going to rewrite my interval over here. 11.095 to 12.905. Okay. Does your interval provide convincing evidence that the true mean for all American adults is different from 12 books? No. Okay, and it provides convincing evidence that the mean is 12 books, but whatever. Okay, so, but we're gonna, go through the motions here for College Board. No, since 12 is in our interval. And this is kind of what I was getting at earlier. If you had a hypothesis test and the ha was mu does not equal 12, right? You see what I'm saying? Like, you would fail to reject because you did not have convincing evidence. What I'm saying is a confidence interval is a hypothesis test. Okay, confidence intervals are always hypothesis tests. Hypothesis tests are always confidence intervals. Yeah, it's like the Venn diagram. Yeah, okay. Okay, confidence intervals are always hypothesis tests. That means that you get a range of values and you can also say if you have convincing evidence or not from the numbers that you get from your interval. You can always make that conclusion, the hypothesis test conclusion, just based off the numbers you get from your interval. Okay. However, if you do a hypothesis test, you get a yes or no answer without any numbers. You don't get a range to use. That's why all dogs are poodles. Wait, no, all dogs are, no, all poodles are dogs, but not all dogs are poodles. That definitely makes sense. Okay. Last thing of the day, and I'm actually not gonna do one of these. I know. This is an algebra problem, but I do want to give you the information that you need. Okay, so going back here, looking at your yellow sheet, I want to remind you, guys, that the part after the plus or minus in a confidence interval is called the margin of error. So if you remember, this was point estimate plus or minus margin of error at the very beginning of chapter 8 when we were learning about the structure of confidence intervals. And if you're given a margin of error, you can solve for sample size. Okay, now don't do this, but let me do this in my notebook. You guys do not need to flip. Just hold on, hold on, hold on. Are you holding? Okay, so back in 8.2b, I told you to use margin of error is less than or equal to critical value times standard error. And then my life hack for you was to just pretend that it's equals, solve, and then round up because this will give you the minimum sample size that works. If you do that, then you won't have to worry about the inequality bit. Okay, so these are simpler because the algebra is simpler. And so what we're going to say is margin of error is less than or equal to critical value times sample standard deviation over the square root of n. Okay. Okay, so what I'm saying is, it's the same thing. Except for you're using the stuff from me, obviously. And you're gonna plug in, so the problem will give you the margin of error. It will give you some kind of percent confidence, it will give you T star, it has to. It's gonna say something stupid and contrived like, research shows that blah, blah, and then you're gonna be like, your eyebrow, gonna go like, this is a good drive math problem, I'm just gonna do it because I'm a math lad. And then it's gonna give you some kind of sample standard deviation, and you're gonna be like, how do you have a sample standard deviation before you know sample size? That's seems wrong, but I'm gonna do it anyway. And then you're gonna solve for n, and then you're gonna take that answer and round it up to take care of the inequality bit. So you don't need to worry about the inequality. Okay. And you're just gonna do it, because, you know, you love me, and I love you, we're just gonna do it, even though we feel like maybe if they had all that information, why would they be solving for sample size? But it's okay, it's okay. Okay, I have a joke for you. Let me make sure that I'm not showing something bad. It says, hey girl, do you ever wonder what life would be like without the central limit theorem? You know, if you're ever not sure how to talk to a girl on a park bench, I feel like maybe this will work.